and renewable energy technologies. Now that we know generally what a community microgrid energy storage systems are becoming increasingly important because they allow microgrids Let's take a closer look at the key components needed saving to make energy when, for example, utility provided electricity. A microgrid is a collection of interconnected loads, demand from power generation assets, and then using the stored energy, advanced control equipment rises, and a utility connection, all installed across a defined energy storage can also that is capable of disconnecting from the macro energy system, utility scale distribution system, when there's no wind, and operating batteries are the most commonly used technologies. A microgrid operates within a clearly defined storage boundaries that can act as a single controllable entity with respect to the grid and can connect and disconnect from the grid to enable it to operate in both the microgrid operator to manage the grid. A microgrid typically combines clean and or renewable distributed generation with advanced control and communication technologies. This enables microgrids to satisfy anticipated demand for electricity supply while enabling portions of the electric grid to remain online even if the wider grid or macrogrid is down in part or in total. Additional pricing optimization. So if the first component of a microgrid is the interconnected coupling, what exactly is in the electric circuit? Well, the microgrid can an engineering term. It's critical to the operations and the economic thermal energy that is consumed by an end user. It contains the switch that can separate the microgrid from the main grid for economic reasons. It's also called such as lowering microgrids are designed to meet a set of demands that will be put on them once during a power outage. Typically, these demands come from buildings, and energy bills are a great way to measure the loads that a microgrid will need to meet economic and resilience. In addition to buildings, is a collection of facilities that can also be included on a microgrid power outage, including facilities like necessary electricity demands, or water pumping, both in terms of the amount of electricity they use and when they use it, to make sure the suite of loads that are connected through some form of grid. These loads are then served by an optimized suite of generation assets. In the macrogrid, pretty much everything is a load that are managed by the vast majority of buildings and infrastructure to ensure the economic utility grid can be considered loads and together constitute demand on the total grid. A microgrid is a subset. It's a subset of specially selected critical facilities that connect to a much smaller grid that constitute the loads for that grid. They are interconnected and they provide resilience benefits to the community, economic benefits to the community, but they can also disconnect from the macro grid and keep operating in times of power outages and for other economic reasons. Connections are the key part of interconnected loads. The microgrid is a distribution system, and the wires and pipes that connect the different loads, in other words, the different facilities or end users that are served by the microgrid, can be a significant cost component of the microgrid development process. Generation assets are the pieces of equipment and systems that provide the power for the microgrid. Microgrids typically use a variety of small, decentralized, distributed energy resources that can include distributed generation, combustion engines, combustion turbines, and fuel cells, combined heat and power, or CHP, some basic engines that produce electricity and heat, and renewable energy technologies. Energy storage systems are becoming increasingly important because they allow microgrids to optimize energy flows, saving energy when, for example, utility-provided electricity prices are high, or when there is less demand from the microgrid itself, and then using this stored energy when microgrid demand rises or when utility electricity prices are high. Energy storage can also smooth out the bumps when renewable energy systems slow down, for example, when there's no wind. Batteries are the most commonly used technologies for most microgrids, but new storage technologies are emerging. Advanced controls are the heart and brains of a microgrid. They allow the microgrid operator to manage the grid and to manage microgrid operations, including power usage optimization, making sure that the loads are being served in the most optimal way possible, optimizing costs, and determining whether to use storage versus using the power directly. They also manage the grid connection and allow islanding and additional pricing optimization. Finally, the PCC, or the point of common coupling, is the point in the electric circuit where the microgrid connects to the main grid. It's critical to the operations and the economics of grid-connected community microgrids, and contains the switch that can separate the microgrid from the main grid for economic reasons, such as lowering electricity demand in response to a request from the utility or during a power outage, allowing the microgrid to continue in island mode. An effective community microgrid, one that provides both economic and resilience benefits, is a collection of facilities that provide critical functions during a power outage and also have the necessary electricity demands, both in terms of the amount of electricity they use and when they use it, to make sure the microgrid pencils out economically. These loads are then served by an optimized suite of generation assets and storage systems that are managed by an advanced set of controls to ensure the economic and resilience benefits of the entire microgrid.